Okay, so find domain and range x-intercepts, right? Both of them say the same thing. We know the basic logarithm looks like right? The domain is x greater than 0. The range is all reals. The x-intercept is, what is that point? It's 1. Okay. What happens to that graph if I subtract 2 inside the function? Right 2. Right. So I'm going to take this whole graph, I'm going to move it to the right. Right. What will that do to the asymptote? It's going to move it. Destiny. Right? Head up. So it's going to take our asymptote, move it 2 to the right. So now it's here. What does it do to the y-intercept or the x-intercept? It moves it 2 to the right. So now it's here. And the graph looks like something like that. That's a bad arrow. So what is the domain now? What's that? No. X greater than 2. What is the range? All real numbers still, right? We didn't change the fact that it goes infinitely up and down. All reals. And the x-intercept is 3. Moved 1 to the right. All right, and then the last one, what does it do to the graph if we subtract the 2 after the logarithm? It's going to take this graph and it's going to move it down. Okay, so now the only point I knew on my graph here was 1, 0. So if that moves down 2, then I'm going to have the point 1, negative 2 right there. Right? Did it change anything about the asymptote? If I take the line, which is on the y-axis, if I move it down 2, still the same line, right? So the graph looks like this now. Okay, the domain is still x greater than 0, right? We didn't move the asymptote, so it didn't change the domain. So x greater than 0. The range is still all reals. Okay, and then the x-intercept. Again, we would have to substitute 0 here. So 2 equals log base 3 of x. And then convert to an exponential. 3 squared is x. So x equals 9. Doesn't look like it, but it's 9.